Okay, now we're going into part B of our probability lecture. And in this lecture, we are going to do more of actually how do you calculate probability. So first of all, we need to start out with what is the formula? The probability of an event happening is equal to the number of favorable outcomes over the number of outcomes in the sample set. The sample space. Okay, so let's look at some possibilities here. If we look first at the sample set of what is the probability of rolling a 1 on a 6-sided dice? So a 6-sided dice, what is my sample space? Oh, let's do something different. Let's make it an 8-sided dice. What's my probability of rolling a 1? That's my event. We're going to roll a 1. Okay, so first of all, what's my sample set? 1, 2, 3, 4, 5, 6, 7, 8. So that means the probability of rolling a 1 is equal to, I have 8 in my sample space. How many of those outcomes in the sample space are a 1? Just one of them. So I have 1 out of 8 chance of rolling a 1, which is going to be equal to 0. I think it is 125, I think. Yep, 125. 0.125, or if they ask for percent, it would be a 12.5%. You only go to percent if they ask for the percent. Otherwise, you leave it in a decimal. Sometimes they'll ask for the fraction, so read your problem carefully. Okay, so that is a very simple example of how to figure probability. If I had a 12-sided dice, well, let's do this one. Let's do the probability of rolling an even number. Well, we know in our 8-sided dice, we know we have 8 samples with event outcomes in my sample space. How many of those are even? Well, remember, even numbers are 2, 4, 6, 8, and 0. So I have 1, 2, 3, 4 of them. So I have 4 out of 8 because there's 4 even numbers that can be rolled. So my favorable outcomes are 4. My total outcomes in my sample space is 8, which is equal to 1/2 if I simplify it, which is equal to 0.5, or as a percentage, it's 50%. Multiply by 100%, and that will give you 50%. So that's my probability of an 8-sided dice. Okay? Now, your probability worksheet is going to use a lot of this particular page that is there in your online system. It's really important that you look at that because every one of these columns is a different sample set. And it's a sample set that is using, in this case, 4 coins, 4 kids, 4 machines either working or not working, and making baskets, okay? So you can look at the various problems in your worksheet. That's the probability worksheet. It's the last page of, I think it's 4 or 5 pages that are given to you to look at. So you can use this page to help you answer those questions in there. For example, it will ask, what is the probability that he will make 3 shots and miss 1? So if I have S is to shoot and not make, and M is to make. So I've got to have 3 M's. There's 1, 2, 3, 4 of them. So there's 4 of them with M on the list that have 3 M's. So there's 16 in my sample space. So my probability of making 3 baskets out of 4. That's my event. What is that? Well, 4 of them make 3 baskets and miss 1. And there's 16 in my sample space, which is 1/4, which equals 0.25, or I have a 25% chance of doing that. So this is how this paper will be used. On the bottom of that page, though, we have a dice chart. You can see it right there. And on that dice chart, we're throwing 2 dice. So we can look at the probability of throwing a 1. Well, if I throw 2 dice, am I ever going to throw just 1 1? No. But what I need to look at, what is my probability of throwing a 1 and a 2? Okay? Well, I actually have 2 of them that do that. 1 2 and 2 1. So the probability, there's 2 of them, and there's 36 in your sample space, which means this is 1/18, which is equal to, let's look at that. Which is 0.055 repeating. 2, 4, 5, 6. I don't usually require you to go out this far, but the book would in this particular assignment. So since that's repeating and 5 is 5 or greater, this is going to round to 0.01, 2, 2, 3, 4, 5, and round it up to a 6. So that's how that is going to work. Another kind, what if they said, what is the probability of having doubles? That means throwing 2 1s, 2 2s, 2 3s, etc. Well, there's 6 possible doubles. So this is 6 possible doubles out of my 36 in my sample, which is 1/6. And again, that 1/6 is going to be 0.1, and then 6 is repeating. So it's going to round up to 6 7 because it'll be 6 6 6 6, making it round up. Okay, what's another probability we often use with this? We often use decks of cards. And used to be, we knew about decks of cards, but today we don't play with them as much as we used to. So you need to know some information about a card deck. When it asks you about a card deck or playing cards, okay, what are some information that you need to know? First of all, you need to know how many cards are in the deck. That's not very clear. Let me move over. That's too dark though. Okay. Playing cards. Okay. 52 cards in the deck. Two. 4 suites. And those suites are hearts, diamonds, clubs, and spades. These 2 suites are red. These 2 suites are black. Okay? So that means there are 13 cards in each suite. Okay, what else do we need to know? Well, we also need to know what else is in that deck. Each suite has 1 card of each. In other words, 1 1, 1 3, 1 of the 4s, okay? And it has 3 face cards. And the reason these are called face cards is they are Jack, Queen, and King. Those are the 3 face cards that are in each suite. So, in a suite of 13 cards, you have 10 cards with 9 cards with numbers. You have an A for an ace, and then which is the number 1, and then you have 3 face cards. So we have an ace, then you have the numbers 2 through 10, and then you have Jack, Queen, King. Those are the cards that are basically in a deck of cards. And you will need this knowledge to work with card decks, okay? So that's how we calculate basic probability. And that's the information you will need to know about card decks to be able to work basic probability questions. Okay, now if you have questions, be sure to contact me and I will try to help you. And we're going to go on to the next video.